in the later part of chapter 5, what we've been focusing in on is factoring these crazy looking polynomials so we could split them and solve and get answers, right? So today on this section, we're going to be covering the remainder theorem and the factor theorem. A theorem is a simple truth. And the remainder theorem says if a polynomial p of x is divided by a binomial x minus r, then the remainder is a constant, which is the same as that value here. If you were to plug it into the original p of x function, you'd get that same answer as the remainder. That sounds complicated, right? But let's do something to make it a little more understandable. We have this example that they tell us divide p of x, which is right here, by this binomial x minus 3. So we know synthetic division. I already set it up for you. You guys remember synthetic division? Okay, so what goes, normally I don't have a box, I just have like a reverse L. What goes inside this box? The opposite of what you see here, right? The opposite of what you see there. Okay, and then what goes over here? The coefficients, and you have to have every term represented, so the -3, the 5, and the 4, right? And I hope we remember that as you go down, you combine -3 plus there's nothing there, so that's simply a -3. And then as you go up, you multiply -3 times -3 is 9, -9. And as you go down, you combine 5 and -9, -4, thank you for your help. And 3 times -4, -12. And this last one, we put a line because this last one's going to be our remainder. And what's our remainder? -8. So here's our remainder, -8. Okay? So I could have done long division. Well, that's horrible. But the remainder would be -8. So what the remainder theorem says is I could actually use synthetic substitution instead of actually substituting. Because check it out, I want to take the same exact p of x function and replace the x's with parentheses. Here it is, -3x squared plus 5x plus 4. I replace the x's with parentheses, and I'm actually going to plug in 3 just like we plugged in 3 up here. And when I plug in 3 in here and in there, what do I get? What is 3 squared? 9. And what's -3 times 9? And what is 5 times 3? And what's -27 plus 15? It's -12, right? So we really have -12 plus 4. What's that? -8. Same exact remainder as when we did the division. So to sum it up, to make it simple, guys, the theorem above, the remainder theorem, allows you to do synthetic substitution. All right, synthetic substitution. What's the difference between synthetic division and synthetic substitution? Well, when I tell you divide this polynomial by this binomial, what do we plug in? We plug in the opposite of what we see here. But when I say synthetically substitute something, like right here, they want us to plug in -3, right? Right there, you're not going to do the opposite. You're actually going to plug in that exact value, -3 right there. And you're going to put the coefficients of all your terms. And you have to represent every single term from the highest degree 6 down to your constant 20. Are there any terms missing? Which one? X is missing. So we're going to have to put a 0 right there. So this is probably one of the longest, hardest ones where we're actually synthetically substituting. But let me pause right here before we actually do this. On synthetic substitution, we take that exact value of -3 and put it in right there, right? And in synthetic division, once again, you put the opposite. Now, do you guys know why we put the opposite? We put the opposite technically because this binomial, if it were a factor, and we're going to get to that in the next theorem that we're about to cover, if it were a factor, then I could split it and set it equal to 0, right? And if I were to solve that, what would x minus 3 equal 0 actually be? 3. And that's exactly why we plug in the opposite. I never told you why we plug in the opposite. I just always say, whatever you see here, plug in the opposite. But the reason is, if this were a factor, then you'd be able to set it equal to 0 and solve it. +3 + 3, you're actually plugging in a 3. Okay? So over here in synthetic substitution, it's kind of like they give you the answer. It's kind of like they're saying, hey, x equals -3. And they want you to plug it in right here, put a -3, plug in -3, -3, -3. So they're telling you x equals -3, right? So it's not a binomial. It's the actual answer. X equals -3. You're plugging in that value. Anyways, I just wanted to make that difference. On synthetic division, that binomial, you plug in the opposite because technically you solve it to get the answer. That's why you're actually plugging in the opposite. Let's put those coefficients of every single term. The coefficient of the x to the 6th, that's 1. The coefficient of x to the 5th, that's 2. Coefficient of x to the 4th, that's -1. Coefficient of x to the 3rd is +1. Coefficient of x squared is -9. Coefficient of x, hey, there is no x. We have to put a 0. And the constant is 20 at the very end. Like I said, this is as long and as crazy as it gets. As you go down, you combine. 1 plus nothing is 1. Okay, as you go up, you multiply. -3 times 1 is -3. As you go down, you combine. 2 and -3, what do we get? -1. Okay, and then as you go up, you multiply. -3 times -1? 3. As you go down, you combine. -1 and 3? 2. As you go up, you multiply. -3 times 2? -6. As you go down, you combine 1 and -6? -5. -5. And how about -3 times -5? 15. +15. And how about -9 and +15? 6. And how about -3 times 6? -18. And how about 0 and -18? -18. And last but not least, -3 times -8, that's a big one. What's that going to be? 54? 54 is correct. +54, which means that our answer will be 74. So our remainder is 74. Not a remainder, we're not dividing. Our output is 74. Our input was -3, our output 74. If you actually did this math, if you plugged in a -3 right here, in parentheses, did it to the 6th power, plus 2 times -3 to the 5th power, minus -3 to the 4th power. If you did all this, hit equals on the calculator, it will give you 74. So is it absolutely essential that you know how to do synthetic substitution? Not really, because you could always do it the old school way. Plug in -3 wherever your x's are at, do the math, you'll get that same answer, 74. Any questions? This one's a little easier. Find g of 4. So they're kind of like telling you this. They're kind of like telling you, hey, the x value is really 4. Okay, so what are you going to plug in? You're going to plug in 4. Okay, let's write down the coefficients. What are the coefficients? 1, 3, 2, and the constant -50. Put that line. As you go down, you combine. 1 plus nothing is 1. As you go up, you multiply. 4 times 1 is 4. As you go down, you combine. 3 plus 4 is 7. As you go up, you multiply. 4 times 7 is 28. As you go down, you combine. 2 plus 28 is 30. As you go up, you multiply. 4 times 30 is 120. As you go down, you combine. We get 70. And that's it. That's our output. If you were to plug in 4 right here, 4 to the 3rd, that's 64. 4 squared is 16. 3 times, I forget, that's too much math, right? But if you did all that math, you will get 70 as your final answer. What do you guys think?
We write it as 70 or something else?
You would just say that g of 4 equals 70. So do you have to know this? You don't have to. Why not? Because you could always just go back and plug in 4 right here and do the math, and you should get that same answer, 70. But this is called synthetic substitution. I think it's a little bit faster than regular substitution. Let's go to the very important theorem here. This is very, very important, the factor theorem. Again, the word theorem in math means truth. So we're going to talk about the truth about the factors, or about a factor of a polynomial. This is on page 354 of your book if you want a more detailed explanation and examples. But here's the factor theorem. The binomial x minus r, this is simply a binomial, x minus r, It is a factor of the huge polynomial p of x if and only if when you plug in r, your remainder is 0. Okay, how about this? How about this? Let's make this a little more understandable. If I say 12, is 12 a factor of 5? Okay, so if I divided 12 divided by 5, will I get a remainder? Yeah, I'll get a remainder, right? Okay, so what if I said, is 4 a factor of 12? Yes, right? Why? Because, well, 4 times 3 is 12. What's your remainder? 0. So to make this theorem easier, if you take a polynomial and divide it by a binomial and your remainder is 0, then that binomial is a factor. Does that make sense? Okay, if you divide any number by a different number and your remainder is 0, you know it's a factor, right? Same thing, if you take a polynomial and divide it by a binomial and your remainder is 0, then that binomial is a factor. That's what this factor theorem is saying, okay? So here's an example. Determine, they're not sure, they're like, is this a factor of this cubic polynomial equation? I don't know, the only way to determine that is to divide this guy by this guy and to see if your remainder is 0. Kind of like up here, 12 divided by 4, the remainder is 0. Yeah, 4 is definitely a factor. Okay, if you did 12 divided by 5, you'd get a remainder. That's not a factor. Okay, so down here, same thing. Let's actually divide this one by this one, and let's see if the remainder is 0. If the remainder is 0, then it is a factor. Okay, so should we do long division? No. Heck no. What's better? Synthetic division. Okay, so synthetic division, we draw this little box. What belongs inside of that little box? 5. Now, again, I could say, well, why 5? Well, because if this is a factor, imagine you rewriting this whole thing in factored form with binomials, and this is one of the factors, yeah? This is a side note, I'm sorry. But imagine if this was one of the factors, and this whole thing is factored and it was equal to 0. What would you do? You'd set this equal to 0 and you'd solve it, and that's how you get that 5. So that's why we're plugging in the x value of 5, because if you were to split, you'd have x equal to 5 right there. Does that make sense? Yes? No? Okay. So let's continue and put the coefficients. What are the coefficients? 1. Okay. As you go down, you combine. 1 plus nothing is 1. As you go up, you multiply. 5 times 1 is 5. As you go down, you combine. -7 and 5. As you go up, you multiply. 5 times -2. As you go down, you combine. 7 and -10. As you go up, you multiply. 5 times -3. -15. Ding, 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 ding. Remainder 0. Happy face. Why am I happy? Because this binomial, x minus 5, it really is a factor. Okay? Now here's the real fun part. I want to take this even further. I mean, that's the answer. We're done. Is it a factor? Yes, it is. Why? Because the remainder is 0. And the remainder, or the factor theorem, says that if your remainder is 0, then it is a factor. Okay? But here's the really fun part. Let's say I did want to factor this. I just found out that x minus 5 really is a factor. So I need some other ones, but see right here, what we have left over down here, this is what we call our depressed polynomial. Why is it depressed? Well, it used to be the power of 3, and now its power went down to what? 2. So this is technically a depressed polynomial, which is a quadratic trinomial, and we just found out that x minus 5 is an actual factor. So far, my factored form is this, but I could continue factoring this quadratic trinomial. Okay? What times what is my c value that if I combine together is my b value? What times what is -3 that if I combine together is -2? -3 times 1. So I actually, -3 times 1. I actually have completely factored this cubic polynomial to these three binomials using my depressed polynomial. Now, that wasn't even part of this question. It was not. All it asked for was, is this a factor of this? And the answer is yes. Why? Because when you plug in the opposite 5 right in there, you get 0 as a remainder. So yes, it's definitely a factor. But I took it a step further. I took these numbers and I created my depressed polynomial from it, and then I factored that further. Example 2. Given a polynomial, we have this huge 5th degree long disgusting polynomial, and they tell you, hey, this is a factor. They're not saying, is it a factor? If they did say, is it a factor, well, you'd plug it in and make sure your remainder is 0. They're telling you this is a factor. Okay? It says find the remaining factors. They want you to find all the other factors of it. Okay? So if I know that it is a factor, what should I get as a remainder? 0. Okay, so let's do that. Let's actually verify that the remainder is 0. What am I going to plug in that box? Positive 2. And again, because if this were a factor, you would say, oh, I could set this equal to 0 to get my answer. And if you set it equal to 0 and go plus 2, you'd get x equals 2. That's why we're plugging in 2. Okay, now what are the coefficients of the rest? 1, negative 2, 4, negative 8, negative 5, 10. There was no missing terms? No, huh? Okay, we're good. As you go down, you combine. You end up with 1. As you go up, you multiply. What do I get up here? 2. As I go down, I combine. What do I get? 0. As I go up, I multiply. What do I get? 0. As I go down, I combine. What do I get? 4. As I go up, I multiply. What do I get? 8. As I go down, I combine. 0. That's weird. There's a lot of zeros. I guess that'll be nice at the end. As I go up, I multiply. 0. As I go down, I combine. -5. As I go up, I multiply. -10. Now, I am not surprised that the remainder is 0. Why? Because they told us that it is a factor. One of the factors is x minus 2. I already knew that, right? But why did I do this? So I could get my depressed polynomial and continue factoring to find the other factors. Make sense? So what is my depressed polynomial going to be? It's depressed because it used to have this strong power of 5, and now it became a power of 4. So let's rewrite our depressed polynomial. It's 1x to the 4th plus 0x cubed, I'm not even going to write it, plus 4x squared plus 0x, I'm not even going to write it, minus 5. There's your depressed polynomial. Now, of course, if you want, you could put this factor that they gave you to start with, x minus 2, right here in the front. The question is, could we factor this further? Yes. If this were a quadratic trinomial, if it said x squared plus 4x minus 5, then I would be able to do this, right? If it were x squared. But it's not an x squared, it's an x to the 4th. So instead of x's, what am I going to have right there? X squares on both of them. And you do the same process as before. What times what is -5 that if you combine together is +4? What would that be?
5 times -1.
+5 times -1. Perfect. And we do have the x minus 2 that was given to us that was a factor in front. Now, could we factor anything else? Well, the x minus 2, nope. The x squared plus 5, no. If that were a difference of 2 squares, I could do it, but it's not. Right here, we actually do have a difference of 2 squares. So we could factor that last binomial out one more time. So what's that last one going to be factored further? Yeah, x plus 1 and x minus 1. And we have the x squared plus 5 also. And they gave us the x minus 2. That's the completely factored form of that ginormous, disgusting 5th degree polynomial. So they gave us this one and they told us find the rest. Guess what? We found the rest. Now this is awesome because if this 5th degree polynomial were an equation set equal to 0, I would have equal to 0 here, and I know that this 5th degree function would cross the x-axis at 1, at -1. Well, this would be irrational. No, yeah, it'd be an irrational imaginary value. It'd actually be the square root plus or minus the square root of, no, plus or minus I square root of 5. And this would also be positive 2. Anyways, you get the idea. Factoring, you're able to split it and solve, which gives you the x-intercepts. Last one. This one's fun. Why is it fun? Because it's different. Why is it different? They tell us that the binomial 2x plus 1 is a factor of this guy over here. It says find the other factor. Same deal. But this one's tricky. We've never done one of these. As a matter of fact, whenever we did long division and we learned about synthetic division, I told you if your number out here in the front is other than 1, I tell you use long division. Let's not be afraid of this number anymore. Let's actually get the answer of x. See, it says this is a factor. If it's a factor, then that means at the end of it all, I'll be able to write it like that, and one of them is going to be this guy, 2x plus 1, right? So if it's a factor, if it were an equation set equal to 0, then I'd be able to set this equal to 0, and it would give me my answer of x. So what would my answer of x be right here? -1/2, which means that in the box, I'm actually plugging in a -1/2. So this is why I said back in the day when we did long division and synthetic division, I said, let's stick with long division because we're going to end up with fractions and we're scared of fractions. Let's not be scared of fractions. Let's just go with it. So let's write down our coefficients. We have 18, we have 9, we have -2, we have -1. Nothing's missing. Power 3, power 2, power of 1, and constant. That's good. As you go down, you combine. 18 plus nothing is 18. As you go up, you multiply. -1/2 times 18, what's that? What's half of 18, guys? 9, but with the negative, okay? As you go down, you combine. What's -9 and +9? 0. As you go up, you multiply. What's -1/2 times 0? 0. Still 0. As you go down, you combine. What's -2 plus 0? -2. As you go up, you multiply. What's a negative times a negative? Half times 2. +1. And the remainder is 0. Now that didn't surprise me because they already told me. They said this is a factor, which means that the remainder will be 0. We just checked that off. But what do we do with these numbers that are here? We write our depressed polynomial. We write our depressed polynomial. Why is it depressed? It used to be the power of 3. The power dropped. It's now weaker. What's the power now? 18x squared instead of x cubed. Okay? And then the 0 is with the x. You don't really have to write that. And let's bring down the -2 over here as a constant. So what do we have so far? They gave us this binomial, 2x plus 1, and we have our new depressed polynomial right there. So far that's our factored form. They want us to find all the other factors. So the question is, could we factor this further? Let's just focus in on the 18x squared minus 2. What could I do? What kind of factoring could I do? Is there any type of factoring I could do? What's the first type of factoring you should always try to do? GCF. What could you pull out of there? All right, so if we pull out a 2, what's going to be left over on the inside? 9x squared minus 1. Now, that's a beautiful thing. Why is it beautiful? Because we now have a difference of 2 squares. It's a perfect square term. It's a perfect square term. Minus sign in between. That's a method that we learned on factoring, where you do the square root of 9x squared, you do the square root of 1, you plug it into your answer format, you put 1 plus 1 minus. So what are my binomials going to be right there?
3x plus 1, 3x minus 1.
Thank you. Of course, we have a 2 out in front. And that's all we could do. So the completely factored form of this guy is the original 2x plus 1 that they gave us, a 2 that's out in the front, and then the 3x plus 1 that we found, and the 3x minus 1 that we found. Those are all the factors. So they're saying find all the other factors. We would say 3x plus 1, 3x minus 1, and also 2. Anyway, we have a homework assignment, worksheet 5.6. We are skipping 1 and 3. We're jumping right into 9 and 11. This is just synthetic substitution. All right, now on the back side of your worksheet, on the back side of your notes, are the solutions, not the actual worksheet where you're going to do the work. All right, they're the solutions. So I didn't actually type up the worksheet for you because some people need more space than others. So I want you to copy down question 9 in your notebook, copy down question 11 in your notebook, do the work right there. All you're doing is plugging in -3 and 4 for 9, plugging in -3 and 4 for 11. And then we're doing 17 through 27 odd. Again, I want you to copy it down from the worksheet into your notebook and do it. Let's take a look at the worksheet. So on the first part, all you're doing is synthetic substitution, and we're doing 9 and 13, right? And they want us to find f of -3 and f of 4 for each. So you could actually plug in -3 the old school way and get an answer, or you could use synthetic substitution for -3. It's up to you. Do you guys want to do the old school or plug in -3 with synthetic substitution? With synthetic substitution. All right, so what are the coefficients? 1, 3, 2, -50. As you go down, you combine, you get 1. As you go up, you multiply, you get -3. As you go down, you combine, you get 0. As you go up, you multiply. -3 times 0 is 0. As you go down, you combine. 2 plus 0 is 2. As you go up, you multiply. -3 times 2 is -6. As you go down, you combine. -50 and -6 is -56. Ladies and gentlemen, this is our output for the input -3. Synthetic substitution, nice and simple, right? They also want you to do +4, so they want you to also plug in 4, but we already did that on the opposite side in our notes. If you're watching this video and you want to see it, just rewind the video to that portion of it. So 9 and 13, or 9 and 11 are the only ones where we're plugging in a -3 and a +4. The rest are the important stuff where they give you, check out the instructions here, they give you a polynomial and one of its factors. So you have a polynomial and one of the factors. They tell you x minus 3 is a factor of this guy, and they want you to find the rest of the factors. Let's jump to number 17. So they give you a polynomial and they tell you that this guy is a factor. This is exactly how you're going to see it on the final exam, guys. All right, so pay attention. They're telling you that the binomial x minus 2 is a factor. So what should I do? If it is a factor, my remainder is going to be 0. So let's actually do synthetic division, or substitution if you want. But what number am I putting right here? 2. And what are my coefficients? 1, 3, -6, -8. As you go down, you combine. 1 plus nothing is 1. As you go up, you multiply. 2 times 1 is 2. As you go down, you combine. 3 and 2 is 5. As you go up, you multiply. 2 times 5 is 10. As you go down, you combine. -6 and 10, 4. As I go up, I multiply. 2 times 4, 8. Now, I am not surprised that my remainder is 0. Why not? Because they tell us that this is a factor of this. It has to be 0 if it's a factor. If it wouldn't be 0, I did something wrong, or they're lying. This is not a factor. But it is a factor. Now, why did I do this? So I can now write my depressed polynomial. Why is it depressed? It used to be pretty strong. It had a power of 3. Now it drops to a power of 2. So let's rewrite our depressed polynomial with the coefficient 1. 1x to the second plus 5x plus 4 at the very end. So they gave me the binomial x minus 2 being a factor. I now have that quadratic trinomial. Could I factor it using our factoring skills? What is it? X plus 4, x plus 1. So they gave you the x minus 2 and you found the x plus 4 and the x plus 1. So on the answers, they're saying find the other ones. You should have an x plus 4 times an x plus 1 on the answers. And that's what we're doing, guys. Technically, if you wanted to rewrite the whole thing, x minus 2 times these other factors that we just found. If I were to multiply these binomials all together, I will get the original cubic polynomial up here. Good luck.